Welcome to AI Podcast. Today we're digging into a fresh AAAI 2025 paper called KTCE, that's KTCE, on automated creation of reusable and diverse tool sets for LLM agents.
Great. Start me off with the TLDR. If I'm finishing this latte in 2 minutes, what's the punchline?
KTCE takes a bunch of problems, distills the underlying concepts into a lightweight knowledge map, turns those concepts into small, reusable tools, and then evolves that tool set over iterations. The result is an agent that solves new tasks more reliably and transfers better than earlier automatic toolmaking methods.
So it's not just more tools, it's smarter tools. Who's behind it?
The work is led by Zhiyuan Ma with Zhenya Huang and colleagues at the University of Science and Technology of China. And yes, the implementation is public so people can kick the tires.
Nice. Give us the background. Why is automatic tool creation even a thing right now?
Because LLMs are great at language, but not at everything. When you let them call tools like a calculator, a unit converter, a table parser, they get far more reliable. The snag is that hand-building those tools is time-consuming, and many automatic approaches end up making tools that are basically summaries of specific problems. They work on the training set and then, well, kind of sputter when the task shifts.
Right, like having a single-use kitchen gadget that only peels exactly one kind of fruit. What gap does KTCE try to close?
Two big ones. First, reusability. Tools that reflect underlying concepts so they're useful across many problems. Second, diversity. Having a broad enough kit to cover the various sub-skills an agent might need.
And what was missing in existing research?
Methods like Creator, Craft, and Trove push the field forward by automatically inducing tools or compact toolboxes, but they often start from individual solutions, so the tools mirror those solutions. That makes them effective in narrow settings and less portable when the domain shifts. KTCE's argument is, start from knowledge, not from one-off solutions, then deliberately broaden the set.
All right, let's unpack the idea. How does KTCE actually build these tools?
It's a two-stage pipeline. Stage one is knowledge-based tool creation. Think of feeding in a pile of problems and asking, what topics do these touch? What concepts live under those topics? And what key points define each concept? The system organizes that as a simple hierarchy: topics, concepts, key points. And for each key point, it creates a tiny Python function with clear inputs and outputs.
So the tool is like an executable definition of a concept. Can you give me an example?
Sure. Suppose the domain is geometry. One key point might be, the area of a triangle equals half the base times height. The tool is a small function that takes base and height, returns the area, and maybe checks for valid inputs. Another key point could be, 3 lengths form a triangle if they satisfy the triangle inequality. That's a separate function. Because each tool maps to a concept, you can reuse it in many problems, not just the one it came from.
Got it. And stage 2 is evolution, right? How does that work without going off the rails?
They treat the tool set like a population. The agent tries to solve tasks using the current tools. Tools that help yield correct answers get selected. Others get changed through mutation or recombination, say adding unit handling to an area function, or composing 2 small tools into a slightly more general one. Over rounds, the population shifts toward tools that are both useful and broadly applicable.
That sounds like natural selection for code, but how do you keep mutations from turning into spaghetti?
2 safeguards. First, tools remain atomic and simple, small functions with clear contracts. Second, evaluation happens on real tasks. So if a mutated tool doesn't help, it doesn't stick around. It's like a chef testing a new utensil during service. If it slows things down, it goes back in the drawer.
Let's talk experiments. What did they test, and what did they compare against?
They evaluated across mathematical reasoning, algebra, geometry, number theory, and so on, plus tabular reasoning and some scientific question answering. They compared KTCE to strong automatic tool creation systems as well as plain LLM baselines. Key metrics were accuracy on benchmarks, but they also looked at how often tools were reused, how diverse the tool sets became, and whether the tool sets transferred across different data sets and model backbones.
And how did it do?
Consistently better than the baselines. The gains range from roughly the single digits up to the high teens in percentage points, depending on the domain. More interesting to me, the resulting tool sets showed higher reuse and broader coverage, which supports the claim that building at the concept level and then evolving expands what the agent can handle.
So it's not just higher scores, it's a healthier toolbox. Did they find anything surprising when they analyzed the tools?
One theme is that small, well-scoped tools really help. Instead of big Swiss Army knife functions, the system favored compact tools that could be chained. That keeps interfaces simple and makes it easier to combine them in new ways. Another theme is transfer. A tool evolved in one dataset can still help when you swap the data or even the underlying LLM.
All right, let's put our critical hats on. Where would you be cautious?
A few places. First, reproducibility. Evolutionary processes depend on sampling and model settings, so replicating the exact same toolset might be hard unless you match the environment closely. Second, dataset hygiene. Because the knowledge map is mined from problems, you have to be careful about leakage between training and evaluation. Third, real-world operations. Benchmarks are tidy, production tools have flaky APIs, timeouts, and schema drift, and we don't yet see latency or cost analyses here.
So the headline is promising, but there's still engineering to do if you want to drop this into a messy workplace system.
Exactly, I'd add governance too. If your toolset is evolving, you need versioning, safety checks, and tests that gate what gets promoted into the blessed library.
Do they share code or scripts so folks can try it?
Yes, the repository includes scripts for extracting knowledge, creating an initial toolset, running evolution, retrieving tools at inference time, and evaluating performance. It's set up so you can reproduce the pipeline and see the effect of each stage.
Cool. Help me connect this to the broader landscape. What's the novelty in a sentence?
KTCE fuses concept-grounded tool induction with an explicit evolutionary loop, aiming to produce a toolkit that's not just accurate on today's tasks, but broadly reusable tomorrow.
Where would you take it next if you were in the lab this week?
3 things. First, plug KTCE into larger curated tool libraries and smarter retrieval, so agents pick the right tool at the right time without calling 5 things at once. Second, push beyond text math into multimodal and embodied settings, vision, speech, maybe robotics, where the idea of a knowledge map still applies but interfaces are richer. Third, stress test in live API environments and report cost and latency alongside accuracy.
That makes sense. Also, I'd love to see deterministic runs like fixed seeds and documented temperatures just to get a handle on how much the evolution bounces around.
Yes, transparency helps teams decide whether they want a stable toolkit or continuous evolution with guardrails.
All right, quick takeaway for listeners who are skimming.
KTCE says don't mint tools from single solutions. Abstract the concepts first, build small, clear functions from those concepts, then evolve the set based on what actually helps the agent solve tasks. You get better accuracy and broader transfer, with the caveat that real-world deployment will need careful evaluation, versioning, and cost controls.
Nicely put. And kudos to the authors, led by Zhiyuan Ma with Zhenya Huang, for releasing the implementation so the community can learn and build on it.
That's it for today on AI Podcasts. If this sparked ideas for your own agents, try translating a few of your recurring tasks into concept-level tools and see how far that gets you, then iterate.
Thanks for listening, and we'll catch you next time.